Next presentation brings up Tim Kinkead, who is representing the Gates Foundation initiative that we've been working with for the in this last year. So I'll let Tim introduce himself and the initiative. So thanks, Tim.
Hi, I'm Tim Kinkead. I lead a small consultancy that works with organizations like the World Bank and WHO, commercial folks, and also philanthropy on data and technology products. And I'm here today to talk about Gates Foundation initiative around maternal ultrasounds. And I was jealous of some of the earlier speakers who brought a cadre of folks with them. If I had, there'd be folks here from Zambia who were instrumental in the data collection. There'd be folks from Kenya, Empath, who have been critical in the implementation science aspects of this. Some of Steve Kern's staff would be here. There's many folks, Richard Zong, who's the Senior Program Officer of the Gates Foundation, who's responsible for this. So there's many folks, and I'm representing the data elements to this, and fortunate to share this information with you today. So similar to the Helmsley activity, the purpose of this initiative has really been product development, and so there's actually some similarities between them. We're in the maternal, this initiative addresses maternal ultrasounds, and that some of the context behind this, we're thinking about populations primarily in South Asia and Africa. In those locations, a number of the deliveries are done in home, and there's, from an antenatal care standpoint, oftentimes the first visit of a healthcare worker is often much later than what you would see in WHO guidelines. What the opportunity that ultrasounds can provide in this space is the research has shown that when a frontline healthcare worker or those early antenatal care visits, when they're equipped with an ultrasound device, there's an increase in the number of mothers who are participating in those early visits. So there's more mothers, earlier visits. So obviously there's greater opportunity for intervention. And then also there's complementary interventions that are able to be provided at that time. The use case that has been targeted here is pregnancy risk stratification on the ultrasound device, but obviously that sits inside an ecosystem of products. And so the concept here is a product for these nurses and midwives. So I'm going to work my way from from the kind of the context of high ultrasound or high burden for pregnancy, and the context that it's obviously disproportionate in South Asia and Africa, if you look at it from a global perspective, then the device, and then into the data. And so the target profile for the device, there's a number of different components to this. The first and foremost is it being a low-cost device, so targeting a handheld device. Many of you may have seen a butterfly ultrasound device, but looking at a price point of $1,000 or less in there. And other key component is the training element for the person that's using, the nurse or the midwife that would be using this technology, and targeting a day of training as opposed to in a high-income country, obviously the technicians have had substantially more training than that. And then I think I've got AI sprinkled in here. When I say AI, it's AI on both. It's both AI and ML, machine learning, and so there's machine learning opportunities. And so this is software sitting on top of a low-cost device, and what that allows for is the addition of layering additional software products that address additional situations, either within the newborn pathway or in other pathways too. Once the device is deployed and the cost for that is incurred, then the marginal cost for adding additional capabilities using ultrasounds continues to increase. before I leave that concept, I think it's super important to say that this is one device sitting inside an ecosystem of interventions, right? And so the target here was to develop the device, but obviously it sits inside of an ecosystem of interventions. So the activity here, obviously we're training. The key component is building a training set for algorithmic models to run on top of devices, on ultrasound devices. And so then, therefore, we have to go collect a bunch of data, prepare it, and provide it to product developers in industry to put that together. And this includes, obviously, the ultrasounds with the clinical attributes, and we just talked about de-identification of images. Obviously, with ultrasound, there's some less concerns relative to things like bone structures and things like that. We still have the clinical attributes, components. Also, singletons, having the opportunity to have the device detect twins, and so that means you need more data, right, to be able to support those things. And then this becomes a little bit of a game on algorithm training, where we're continually chasing larger and larger data sets to make sure that we have that it's representative of populations. And then a key component here is on that training component, to get down to that one-day training element for the nurses and midwives. Then you need to change the way in which you're collecting, the way in which you're doing the sweep on the ultrasound of the mother. And so to move it from an expert person who knows exactly which angles, and anyone who's seen a maternal ultrasound knows that there's just a very intricate set of wrist movements that are going on there. And the intent here is to have more of a blind sweep, so that you're doing either, an example would be, these vertical passes over, in repeated session. And then there's a couple different elements of it in terms of, you could have the device indicate whether it was a successful sweep, but from a data perspective, we're obviously now moving from kind of these gold standard DICOM images of an ultrasound that any of us who have kids probably have a few of those lying around, to more of a movie format, right? So you're changing the types of data that you need to collect. So this map is the inverse of the map that Rebecca showed in the morning, and kind of where the data is coming from. So a lot of this data was collected in Africa, given the target populations that we're going after. There's been a number of data pooling challenges, obviously. I mean, I'll talk in a second about how this changes over time, because this isn't data that's collected, fit for purpose. We're somewhat in the secondary use standpoint, not in the classical sense of the way in which clinical trial tabular data is using, but we're often repurposing data that was collected for one purpose and building it into a training set, and then making that training set available to product developers. Obviously, so this includes, so we're dealing with institutions from different jurisdictions, and we just heard how the DOJ is affecting America, but when you're operating on a global scale, we have the different jurisdictions that we're working with. We're doing nonprofits, then commercial entities that bring products to scale, and all of them talk a different language. And then when you come to put that into a data sharing agreement, right, that it pops up at that point, kind of the different ways in which different organizations think about the challenges of how they operate. Obviously, we're dealing with projects that are targeting low-cost products, and so you need an affordable data infrastructure. You can't have a very expensive way of collecting this information. And then it's important, especially in when we're dealing with some of our academic partners who may have expertise in a specific domain. They may not have expertise in some of the data sharing requirements, especially given that in some of these geographies, some of the regulations are very relatively new compared to other folks. And then image data creates a different set of challenges relative to tabular data. especially if you're trying to transfer large sets of images from poorly internet-connected areas. But just from a standpoint of the repository, there's new capabilities are needed, including image viewers, the ability to, from a data quality standpoint, to make a change to one image in 300 or 500 images. You're not just changing a cell in a spreadsheet, in a CSV file and uploading it. There's just some additional support that's needed from a technology standpoint. All right, I mentioned about over time, how this changes over time. And so I thought it might be helpful to divide this into kind of 3 time periods and label the first one kind of the retrospective data collection, and where we're looking to take existing data that has been developed, that has been collected, and then use it for the initial purposes. And so a first step in there is just ensuring that the algorithm is viable, right? That can you have an algorithm establish, pick out the signal and the noise. And so that was done in this project. Early on, there were a number of different things where there were a number of different partners who were doing gestational age prediction off of straight DICOM images. Then we moved into more of a prospective data collection, and I've heard the image collection described as kind of this hodgepodge process, but because in this phase, that was when there was the addition of the blind sweeps into the data sets, and then there were implementation science initiatives going on to evaluate the training. Well, there are images there, and that those can be collected. Oftentimes in these activities, we see an improvement of data quality occurring at this point, where either deficiencies in attributes that were collected that weren't collected early on, or if there were just errors, that those things are collected. I think what's interesting is thinking about where this moves from a future standpoint, because we're training algorithms. And because we were talking, there was a discussion about off-label uses. I could imagine off-label uses of ultrasound devices, and the intended use here is a first trimester situation. But I think it's important that as we think about how different devices could be used over time and expanded use cases, making sure that we're updating those training sets so that we're not having existing algorithms using data, having too limited of a data set. I also thought it was interesting, the first thing we do on data is we strike out unstructured data, right? If we see a free text field, immediately our reaction, certainly for the last several decades, has been to strike that information out of there. But some human somewhere took the time to write down something that they felt was important. And we've never really had the opportunity to take advantage of this before. We don't even have the kind of the tools to cost effectively evaluate whether there's a name in it. So we just strike it out as a point of practice. But I could imagine that given the way in which some of the probabilistic models that we're developing, that we may be able to take much greater use of that information over time. And so I think that's going to put stresses throughout the system, from data collection into repositories like Vivly, so that we can make that data available. I think another component of this is where what's kind of pre-competitive data. I thought it was really interesting hearing about using the control arms and the sharing of the control arms, and obviously, and how that allows for kind of this more pre-competitive, if you will, sharing of information, where we're not having to go head-on into commercial confidentiality concerns. And I think that thinking about how these data sets can be developed for training algorithms using pre-competitive data, and then leaving data out that may allow for market differentiation may be an opportunity. So Vivly is now going to be the repository that will be enabling all of these data transfers, and there's a number of keys to success. And I've been involved in a number of different collaborations that include multiple institutions. And there's just some really important elements that have that make this a successful activity for these ultrasounds. I think that the biggest one is the ability to add new partners and having it have a lower incremental cost per partner add, if you will, because the University of North Carolina has been instrumental in this initiative and is one of the holders of, is one of the data fiduciaries for some of the large data sets. And if they had to go create a data sharing agreement for each time there's a commercial partner added, that's a significant burden to them. And so that's been critical. Supporting partners understand kind of what privacy law means and how to help them anonymize their data. Those are important capabilities. And then there's been some discussions today around speed. And I think like when you're developing products, the faster you get a product to market, the more successful births you can have. So being able to work with a partner like Vivily who can move move our partners through the process of signing up with data contribution agreements and understanding the complexities of anonymization, and then supporting the sensitivities that occur between partners. Those are and doing that at speed is super important. And then other obviously cost-effective data mechanism is a key component. All right. Yeah, thank you. Are there questions?
So I had a question. Sorry. Thanks so much, Tim. I thought that was a really great summary of what has happened and what you're thinking about on the product side. Do you see similar projects coming down the pike as this one for the foundation?
For the foundation, yeah. I mean, I can't speak for the foundation, but obviously there's a number of activities. I think that one of the things that I see funders, including the Gates Foundation, have a strong interest in the transformative capabilities of AI, including ML, especially in low resource settings, as an augmentation for both the kind of the training component to overcome kind of with humans in the loop, but potentially reducing some of the training components. So, and I think that there's a lot of studies being done now on ultrasound devices. You could easily layer, as I said earlier, layer new capabilities on top of the same device. If the device is already, has its CE mark, it's already out, it's already deployed in the field, and that capital expenditure has already occurred. There's a number of papers around lung ultrasounds and the potential for lung ultrasounds around TB and pneumonia. And so, I think that there's promise there and opportunities there. So I believe that there'll be an expansion. Certainly beyond this use case. Yes, Steve's the ringer in the room.
A quick question. It seems to me once these are deployed for first trimester, they're going to be used not just but more quickly for second trimester, third trimester, where you could continue to make diagnostic sort of insights in terms of fetal abnormalities, preeclampsia, gestational diabetes, small for dates, all these other things. Are you continuing to do that research, or are you going to let that happen?
Certainly, I'm not doing that research because
okay.
I'm not.
I get it. But
yeah,
is that continuing in some way?
Yeah, I believe it is my belief that this is going to be a rich, avenue, right? Like the intent. I think that the intent behind the excitement around low-cost ultrasounds is this is the breadth of the device deployment and kind of how that changes how quickly and how often women are showing up for antenatal care. Then once there, you can go into the grants database and you can see a bunch of things around preeclampsia. There's been a lot of work, and there's some really great work done out of UCSF on preeclampsia. And yeah, I would imagine, a lot of people are looking for biomarkers. And so I think that's where it gets really interesting is how you could layer in additional data. What data could you layer in, inexpensively, right, at that point of care, right?
Yeah, and I think one of the points that Tim's trying to make is if you do that preemptively, thinking about it at the front end, like we heard our colleagues from this morning on diabetes talk about things you're thinking about what's going to happen in the future, right? Then you actually become somewhat enabling. So this first data set and all the mechanisms of how to get it in place really helps then for somebody who wants to add something onto that as a next data set, right, as an example. And this is over 12,000 women ultrasound scans. If you're a funder of that kind of study, you don't want to fund that again if you can help it. So one of the things that could be nice is that there's going to be an initial set of algorithms that come out, and you might have your kids go to school and they're in a tech program and they go, I can make a better algorithm. And so they get access to the data and they create their own algorithm from it, and then they test it against it, and they can show, I can get better at estimating gestational age than you, right? And so it starts to a little bit to democratize the process because the data is available as an asset. Now the differentiator, and Tim, you alluded to this a little bit, is some of the features that some groups might have versus others. But this right now will tell you from those blind sweeps, gestational age, fetal orientation, so head up, head down, multiple gestations. They were trying to look at some other things, but they don't have enough data for more than that. But you can then put that into an algorithm for risking a pregnancy and going, this is something that I have to keep my eye on. This is normal pregnancy going fine. So it's really helpful from a management standpoint. And you really, we could spend an hour in this room and you could all do gestational age estimations within plus or minus 5 days before you left today. It's really simple.
0.
Two questions. One, I'm curious about your thoughts on the training sets and how diverse should they be to answer more general questions. So if you are training the set from certain locations, would you then use that product for those locations, or would you go and put the product everywhere in the global, and then would that be applicable to everyone that's using that product? I'm curious about your thoughts on that.
Yeah, that's a fantastic question. And I think that because I spend a lot of time thinking about what's the value of data and then what's the value, because there's a cost to even, it would be very easy to say that, all philanthropy should make all their data open, right? Like that's a common piece, but there's a significant cost associated with that. And so it makes sense, and it's the same thing I would imagine from a pharmaceutical industry, right? That how do you incur that cost? So I think that the piece that I didn't talk about, because it's not been prominent in this initiative, but it's prominent in a lot of other initiatives, is having some sort of data coordination center, and and it really dividing up like kind of responsibilities. And from a data coordination center, Vivly can provide the data like some of the traditional things that have occurred in a data coordination center from an infrastructure standpoint. But then that leaves an opportunity around for a domain expert to step in and really think about like kind of what's a product manager, if you will, for what does that data set, what should be in that data set. And and that evolves over time. I think that going back to my 3 phases, I feel like in the first phase you're really in that proof of concept phase, and that's some of the things that Steve's team did really well, both when he was at the foundation and later at GH Labs, is really proving out the concept. And that middle phase is when the critical mass of interest really starts to form, and there's more self-generating interest, and commercial entities were interested in participating, and I think it's at that point you need the person who's got enough domain expertise to understand like the signal and noise and the data, and understanding what are the key features. Like when you start thinking about those multimodal applications, right, getting really super specific. It's like, these are the types of data elements that we need, or is it even feasible to collect that in a low-income setting, and then making sure that it's added into the training set so that it's available to the product developers.
And I guess you can do pilot testing, like what you can develop the product and then test it in the spaces.
Yeah, it's not, I mean, you could easily get a little bit of data just to update for a region. But, again, this is another area where, at least in preterm birth, it's very controversial, right? If you're Stephen Kennedy and you did the Intergrowth 21 study, you believe that irrespective of where mom lives, they can all birth the same, more or less sized babies. Humans give the same sized babies if you feed them all the moms the same way and you give them all the same attributes, right? So that there isn't a cultural, geographical, genetic difference. Now, that said, if you look at the reality, there's differences in average births across the whole world, right? So India is making a version of this product only with Indian babies, and only Indian companies that are doing this, right? So you'll see, and is that the right answer? Yeah, it's hard to, it's still, I think, being debated, but having important recognition of the context is key to be able to use these successfully, I think, as products.
Yeah, I believe that relative to the localization issue, that's another topic that I've been digging into deeply to try to anticipate what data needs there are. And I think it's always, and then ideally, what are the generalizable ways across domains? But I'm not convinced that that's generalizable across domains. That I think that really, and I think that we see this in regulatory filings, right? Like when you go toward what's generalizable, but what should be local, local. That it's very much it's specific to the situation. And on the nutrition, specifically on Stephen Kennedy's point, and Eric, the first author, was on that team. I think that that's one of the reasons why it's so important. There's an opportunity and a role for Vivly around updating the data sets, right? Because I think in the current model, you're making, there's a submission and then you're done. But if that calcifies the nutritional challenges that occurred that resulted in slower growth of the fetus, right? Then your algorithms can be off. So as you fix the nutritional problem, you got to go update your data set. All right.